In this video, I'm basically just working problems from the worksheet. The link for the worksheet is right above this video. Okay? I'm doing the odd problems. Alright, here we go. When I look at this problem, the only technique we have for factoring a quadrinomial or a four-term polynomial is grouping. When I say the only technique we have, I mean my class at this stage. I'm not claiming that there are no other techniques. Okay, so here we go. So I'm going to factor this by grouping. When we group these two together, there is a common factor of x squared. X cubed divided by x squared is x. Minus 2x squared divided by x squared is minus 2. Here, common factor is 2. Positive 2. That leaves x minus 2. Note, if you don't get the same things there, something went wrong or the technique is not going to work. Alright, we take the x minus 2 out. When we take the x minus 2 out of this part, it leaves x squared. Take x minus 2 out of this part, it leaves a positive 2. We check here. When we factor, we're going to factor over rational numbers or integers. We're not going to factor over complex numbers. This could be factored over complex and irrational numbers, but we're not going to factor that. So we're going to leave this alone. Okay. At this stage, we cannot factor sum of two squares. And 2 is not a square either. So, okay. So this is our final answer for this part. Number 3. This is a classic trinomial. Right. Note that the exponent here is twice the exponent here, and this one doesn't have it. Doesn't have x. So we're going to factor it like it's a quadratic. And when we come down, we're going to split up the exponent evenly, x squared, and that's where that middle term is going to come from these x squares. Alright, so in a traditional method, what are the factors of 9? They combine to make negative 10, negative 1, negative 9. Okay? Alright, now we re-examine our factors, and we notice that they're both difference of two squares. So we can continue factoring. That's x minus 1, x plus 1, x minus 3, x plus 3. That's it. Number 4. How can you tell if you're finished? Well, you look at each of these. If the exponent is 1 or less, you cannot factor anymore, unless there's a common factor. If there's a common factor, we should have dealt with that at the beginning. All right. Okay. Moving on. Number 5. This is a difference of two cubes. In fact, I think I remember doing this one on one of the videos. Cube root of x cubed is x. Cube root of 27 is 3. Square the first term. Change the sign. Multiply the two terms. Square the last term. Plus 9. 6. Oops, not 6. I'm doing the odds. 7. Okay, 7 looks like a long problem. We're going to write that on a separate sheet of paper. Okay. We're going to treat this like a quadratic to begin with. We'll take half that exponent. What are the factors 16 to combine to make negative 17? Negative 16, negative 1. Again, we have difference of two squares again. X to the fourth is a perfect square. So it's x squared minus 4, x squared plus 4. Same with this one, x squared minus 1, x squared plus 1. These two, x squared plus 4 and x squared plus 1, cannot be factored any further. I'm going to move those to the end. X squared minus 4 and x squared minus 1 can be factored. So we say x minus 2, x plus 2. I'm copying the unfactorable one. Factor x squared minus 1, x minus 1, x plus 1. Copy the unfactorable one. This is final answer for number 7. Number 8. Urgh, I can't count in odd numbers. Okay, 9. Doing 9. X to the 5th plus 12x cubed plus 35x. Ah, common factor. There's a common factor of x. Take that out. Now it's a nice little trinomial in quadratic form. Right, but this is not a quadratic. We're just going to treat it like a quadratic, the way we factor a quadratic trinomial. So we take half the exponents, split the exponents evenly. Now what are the factors of 25 that combine to make, factors of 35 that combine to make 12? Positive 7, positive 5. Check to see if this is further factorable. That's a square, but these are sums, so we're not going to factor those. So that's it. That's number 9. Number 11. Okay, this is another grouping problem. Group those two, group those two. Take out an x squared, leaving me 3x minus 1. Take out a 3. No, take out a 2, sorry. That'd be 3x minus 1. Take out a 3x minus 1 out of both. That leaves me x squared plus 2. It's a square, but it's a sum. I'm not going to factor that. That's number 11. Number 13. Excuse me. Okay. Well, you look at this and you hope something comes out, but nothing comes out. So we can use the Lizzie method. Alright, it's quadratic. It's a trinomial in that quadratic form. So we're going to try the Lizzie method. I'm going to do 4 times 225. What's that? 900? Is that 900? 4 times 25 is 100. 4 times 2, 8, 900. Okay. Sorry if that confused you. You can use a calculator or however else technique to get to 900, but it's 900. What are the factors of 900 to combine to make 109? Well, that's actually kind of nice. It's 109. So, Lizzie method says we're going to go ahead and split that evenly. Split the exponent, that is. And we need a negative, so both of these have to be negative. So it's minus 100 over the leading coefficient of 4. Minus 9 over it again, the leading coefficient of 4. Reduce the fractions, and this one becomes 25. This one doesn't reduce. I should have done something else. Let me rewrite that again. Bring the 4 up. Ugh. And you can factor even further, because this is a difference 2 squares, and this one's a difference 2 squares. So this becomes x squared minus 5, x squared plus 5, 2x minus 3, 2x plus 3. Sorry, 2x squared. Okay. Now, these two are minuses. These are differences, so one might think you can factor those. But the 3 and the 2, the 5, they're not perfect squares, so we're going to stop factoring. That's the final answer for 13. We're going to stop the video there. I'm going to do the rest of the worksheet on another video. Okay?